Hi friends, I want to show you a very perfect trigonometric method for solving the length of this side b. But let me tell you, I'm not the one who solved it. It was actually solved by a great mathematician with the name Mr. Xu Alin, and he wants to share this amazing method of his with everyone. So let's see. We are to calculate the length of this side b. We have the length of this side to be 100 meters. The length of this side is A, and this is also A. That proves that they are congruent. We have the size of this angle to be X, and this is also X. So how did he do it? He started with this triangle here. It is a right angle triangle, but he used the sine rule to relate this side and this side. Let's assume the length of this part to be C. So by sine rule, the sine ratio of this angle 2x divided by this side A must be equal to the sine ratio of this angle 90 degrees divided by the length of this side, which is the sum of this B and this C. So sine 2x over A equal to sine 90 degrees over B plus C. Sine 90 degrees is 1. So sine 2x over A equal to 1 over B plus C. We keep it aside. Now come to this big triangle. We have the size of this angle to be 90 degrees. And this is the sum of this 2x and this x. Based on the rule that the summation of angles in a triangle is 180 degrees, this angle must be 180 degrees minus 90 degrees minus 2x minus x. 180 minus 90 is 90. Minus 2x minus x is minus 3x. So the angle is 90 degrees minus 3x. Now focus on this overlapping triangle. Use the sine rule once again to relate this side and this. So by sine rule, the sine ratio of this x divided by this side A is equal to the sine ratio of this 90 degrees minus x divided by this side, which has its length to be the sum of this B and this C. So sine x over A equal to sine 90 degrees minus 3x over B plus C. Now divide this equation by this. So sine 2x over sine x over A equal to 1 over B plus C over sine 90 degrees minus 3x over B plus C. This A cancels this A. Similarly, this B plus C cancels this B plus C. So sine 2x over sine x equal to 1 over sine 90 degrees minus 3x. Now from trigonometry, there is the double angle identity, the sine 2 theta equal to 2 sine theta cos theta. We let theta equal to x and substitute here. So sine 2x equal to 2 sine x cos x. Replace this sine 2x with 2 sine x cos x. Now this sine x cancels this sine x. So 2 cos x equal to 1 over sine 90 degrees minus 3x. We know that sine 90 degrees minus theta is cos theta. Replace theta with 3x. So sine 90 degrees minus 3x equal to cos 3x. That is, this sine 90 degrees minus 3x is cos 3x. So 2 cos x equal to 1 over cos 3x. Multiply both sides by cos 3x. Here cos 3x cancels cos 3x. And here 2 cos x times cos 3x is 2 cos x cos 3x. So 2 cos x cos 3x equal to 1. Now still from trigonometry, there is another identity that 2 cos m cos n equal to cos m plus n plus cos m minus n. Let m be 3x and n equal to x. Substitute here. Now 2 cos 3x cos x equal to cos 3x plus x, which is 4x, plus cos 3x minus x, which is 2x. So 2 cos 3x cos x equal to cos 4x plus cos 2x. We come here, replace this cos x cos 3x with cos 4x plus cos 2x. So cos 4x plus cos 2x equal to 1. Still from trigonometry once again, there is another identity that cos 2 theta equal to 2 cos squared theta minus 1. Assume theta equal to 2x. Substitute here. Now cos 2 times 2x, which is 4x, equal to 2 cos squared 2x minus 1. So cos 4x equal to 2 cos squared 2x minus 1. Come here, replace this cos 4x with 2 cos squared 2x minus 1. So 2 cos squared 2x minus 1 plus cos 2x equal to 1. Take 1 to the left. So 2 cos squared 2x minus 1 plus cos 2x minus 1 equal to 0. This minus 1 minus this minus 1 is minus 2. So 2 cos squared 2x plus cos 2x minus 2 equal to 0. Now take a duplicate of the equation here. Assume cos 2x equal to y. Now this cos squared 2x is same as cos 2x all squared. Cos 2x is y, and this cos 2x is also y. So 2y squared plus y minus 2 equal to 0. It is a quadratic equation. By the quadratic equation formula, for any equation in the form ay squared plus by plus c equal to 0, y equal to minus b plus or minus root of b squared minus 4ac all over 2a. So comparing this equation with this, we can obtain that a equal to 2, b equal to 1, and c equal to minus 2. Substitute these values here. Now y equal to minus 1 plus or minus root of 1 squared minus 4 times 2 times minus 2 all over 2 times 2. 1 squared is 1. Minus 4 times 2 is minus 8. Minus 8 times minus 2 is plus 16. 2 times 2 is 4. So y equal to minus 1 plus or minus root of 1 plus 16 all over 4. 1 plus 16 is 17. So y equal to minus 1 plus or minus root of 17 all over 4. And from this, it's either y equal to minus 1 plus root 17 all over 4, or y equal to minus 1 minus root of 17 all over 4. Recall y is the cosine ratio of 2x, and this y is same as minus open bracket 1 plus root of 17 all over 4. The cosine of 2x can't be negative, so cos 2x equal to minus 1 plus root of 17 all over 4, which is root of 17 minus 1 all over 4. Keep it aside. Now look at this triangle. Use the SOHCAHTOA. Taking this angle as theta, this will be the adjacent and this is the hypotenuse. From here, cos theta equal to adjacent over hypotenuse. Theta is 2x, adjacent is 100, and hypotenuse is c plus b. So cos 2x equal to 100 over c plus b. Multiply both sides by c plus b. Here c plus b cancels c plus b. And divide both sides by cos 2x. Here cos 2x cancels cos 2x. So c plus b equal to 100 over cos 2x. Recall from here, cos 2x equal to root 17 minus 1 over 4. Substitute here. So c plus b equal to 100 over root of 17 minus 1 all over 4. 100 over root of 17 minus 1 all over 4 is same as 100 divided by root 17 minus 1 over 4. We can change this division sign to multiplication by bringing this numerator down, the denominator up. 100 times 4 over root of 17 minus 1 is 400 over root of 17 minus 1. So c plus b equal to 400 over root of 17 minus 1. Multiply by the conjugate of this root 17 minus 1. That is root 17 plus 1 over root 17 plus 1. 400 times root 17 plus 1 is 400 open bracket root 17 plus 1. While here root of 17 minus 1 times root of 17 plus 1 is root of 17 times root of 17 plus root of 17 times 1 minus 1 times root of 17 minus 1 times plus 1. Square root of 17 times square root of 17 is 17. Square root of 17 times 1 is square root of 17. Minus 1 times square root of 17 is minus square root of 17. Square root of 17 minus square root of 17 is 0. Minus 1 times plus 1 is minus 1. 17 minus 1 is 16. This 400 divided by this 16 is 25. So C plus B equal to 25 open bracket square root of 17 plus 1. Now look at this triangle. Because of this right angle here, it is also a right angle triangle. So he used the SOHCAHTOA, taking this angle as theta. This is it, and there is the hypotenuse. We know cos theta equal to adjacent over hypotenuse. Theta is 2x, adjacent is c, and hypotenuse is 100. So cos 2x equal to c over 100. Multiply both sides by 100. Here 100 cancels 100, while here cos 2x times 100 is 100 cos 2x. So c equal to 100 cos 2x. Recall from here, cos 2x is square root of 17 minus 1 all over 4. Substitute here. Now c equal to 100 times square root of 17 minus 1 over 4. This 100 divided by this 4 is 25. So c equal to 25 open bracket square root of 17 minus 1. Now he subtracted this equation from this. C plus b minus c is b. 25 open bracket root 17 plus 1 minus 25 open bracket square root of 17 minus 1. We can factor out 25. So b equal to 25 open bracket square root of 17 plus 1 minus square root of 17 minus 1. Minus open bracket square root of 17 minus 1 is minus square root of 17 minus minus 1. Minus minus 1 is plus 1. This square root of 17 minus this square root of 17 is 0. 1 plus 1 is 2. 25 open bracket 2 is 25 times 2, which is 50. So b equal to 50. That is, the length of this side using his method is 50 meters.